Welcome to Burlap Teachers. Enjoy the video.
You start by preparing essential tools and a minimal plan. Install a modern C++ compiler and a linear algebra library. You need reliable matrix ops. Once done, create a CMake project and a single main. CPP to iterate quickly. Initialize basic data structures, vectors for inputs, weights, biases. Make sure to use float or double consistently to avoid silent precision bugs. Now implement a forward pass function stub. This first actionable step unlocks the network skeleton and makes later integration straightforward. You now build the computational heart. Implement matrix multiply, bias addition, and activation functions like ReLU or sigmoid. That is your forward pass. Next, derive and code backpropagation for each layer, compute gradients for weights and biases, then support minibatch accumulation to stabilize updates. Also add a loss function such as mean squared error or cross-entropy, and include numerical stability tricks like clamping or log sumx. Once complete, tie these into a training loop and test with a tiny dataset. You finish by wiring the training loop. Shuffle, create batches, run forward, compute loss, backpropagate, and update weights with your optimizer. Validate regularly on a holdout set and log loss and accuracy so you can watch learning progress. Make sure to implement simple checkpoints and a decaying learning rate if needed. If things go wrong, check gradients and weight initialization first. Mismatched shapes or a too large learning rate usually explain failure. Finally, iterate and refactor for clarity and performance.
Thanks for watching. Consider subscribing if this video helped you.